Yeah, I chose the analysis of test case prioritization techniques for web applications. I chose this topic because I had a course last semester at Utah State University on this topic. It was a software testing course. And we just looked at prioritization techniques, but we didn't analyze fault-finding effectiveness for these prioritization techniques, so I thought it'd be a good thing to take further in this class and look at. So the agenda that I'll be following is first I'll go over the motivation for the project, and then I'll explain my approach. I'll explain what user session-based testing is, explain the prioritization criteria that I use, and I'll explain about the subject application used to create the test suites and all that. And then I'll go over the evaluation of each prioritization criteria, how I evaluated them, and results and analysis and conclusion. So, the motivation. Many web applications today, or web applications are used in many aspects of our lives today by businesses, consumers, the government. So these web applications need to be reliable. And not only do they need to be reliable, many of them need to be available 24/7. So they need to have quick and efficient testing strategies so they can be available and be working. For my approach, I implemented an existing scheme that is in this paper called Prioritizing User Session-Based Test Cases for Web Application by Sampath et al. It talks about user session-based testing, and I'll go over what that is more on the next slide. So essentially what I'm doing is I'm taking a test suite made up of sessions, test cases, and I want to be able to prioritize these test cases so the most important ones are first, and so I can detect faults as quickly as possible. So I'll be using various prioritization criteria and evaluate the fault detection rate of each criteria. So user session-based testing is being able to use data gathered from actual users and use that for testing. Many web developers use user session-based testing for regression testing. For instance, when they roll out a new version of a web application, they'll use regression testing based on, or using data from older versions of the web application, and use that data to test the new version to make sure it's working correctly and everything. This is an example of a session that I used, and it's an XML format. It's made up of a series of base requests, and these base requests can be classified as either gets or posts. Posts are a request that requires some sort of input from the user. For instance, for the parameter username, the value is test, and these are called parameter value pairs, and each parameter can have one of many values. So there's a couple parameter value pairs that you get. This is the list of the prioritization criteria that I use to order my test cases, and I'll go over each of these in more detail in the next slides. First, I have test length based on number of base requests, test length based on number of parameter values, unique coverage of parameter values, two-way parameter value interaction coverage, frequency-based prioritization, which includes the methods most frequently accessed sequence and all access sequences, and then random ordering. So in ordering by test length, there are two cases that can be considered. First, we can order by number of base requests, and we can also order by number of parameter values. And for each of these methods, I order in both ascending and descending orders and analyze each of those. So the test cases are just ordered by the number of base requests of parameter values that they contain. When ordering by unique coverage of parameter values, I want to order the test cases so that all parameter values in the test set or in the test suite are covered as quickly as possible. For instance, this is a list of 4 parameters: login, member type, discount status, and shipping method. And they can each take on one of 3 values. These are the values that they can take on. So for this example test case, new member, silver, free shipping, and standard, This is the parameter values that it covers. It covers login, new member, member type silver, discount status, free shipping, and shipping method standard. So to cover all of them as quickly as possible, we just need to finish covering the rest of the parameters. So for two-way parameter value interaction coverage, it's like the previous example, but in this case we're not ordering the test cases to cover just all the parameter values. We're trying to cover all of the parameter value interactions between two pages. So here's another example using the same test case. So this test case covers the following parameter values: new member and silver, their parameter value pairs between two pages. So new member free shipping, new member standard, silver free shipping, silver standard, and free shipping standard. So this set of parameters, for this set of parameters, there are 3 to the 4th power number of parameter value interactions that need to be covered. Okay, so for frequency-based criteria, this is one of the methods. MFAS stands for most frequently accessed sequence, and the idea in this case is to identify the most frequently accessed page sequence, which is a series of 2 base requests. I'm only using 2 base requests for my experiment. And we want to order the test cases in decreasing order depending on how many occurrences of this page sequence they have. So we want to, first of all, we identify the sequence, and then we order the test cases based on how many occurrences of that sequence they have. AAS stands for all access sequences, and it's basically an extension on most frequently accessed sequence. And in this case, we use the frequency of all the sequences in the test suite to order the test case, or to order the test suite. So here's the algorithm. First, we start with an ordered list of all page sequences from S1 to Sn. And so S1 here would be the most frequently accessed sequence because they're ordered from most frequently accessed to least frequently accessed. So starting with the most frequently accessed sequence, we randomly choose a test case that has the most occurrences of that sequence because there may be more than one. So we randomly choose a test case. And then we look at how all the other sequences that test case covers and remove those sequences from consideration. And then we get the next sequence that hasn't been covered and repeat the sequence until all the sequences have been accounted for. And when all the sequences have been accounted for, we randomly place the remaining test cases into the test suite. So this is the application that was used in order to create the test suite and the faults. It's called Schoolmate, and this application was created specifically for my software testing class in order for us to experiment with it and everything. And its functionality is essentially the same as RAMCT. You can log in and register for classes and look at your grades and all that. And teachers could log in to give grades or assignments, and then administrators could log in to create classes and do things like that. And faults, so these tests were created by my students in my class and myself. We logged the application a couple times over a couple weeks and created these test cases. Our sessions were recorded and they were printed out in XML format. And then faults were seeded by various graduate and undergraduate students that were appointed by our professor. So this is some of the characteristics of our subject application and the test suite. There were 24 faults seeded into it. This is the total number of user sessions that were created by my classmates and I. There were 5,173 requests in the entire test suite. The largest user session in number of requests was 192, average user session was 35. Total number of unique parameter values in the entire test suite was 2,249, largest user session and average user session. And then the final number is total number of two-way parameter value interactions in the test suite. So there were 5 types of faults seeded in the application. First, we have data store faults. There are faults that exercise application code interacting with the data store. Logic, which are application code logic errors. Form, which are modifications to parameter value pairs or form actions. And appearance, which are faults that change the way in which the user views the page. And links are faults that, or link faults are faults that change the hyperlinks of the page. So the evaluation metric is rate of fault detection. And rate of fault detection is the measure of how many faults are detected by a subset of the test suite. And I was interested in, number one, finding the most faults in the earliest test cases, and number two, which methods located 100% of the faults earliest. And here's a graph of the detection of faults for each prioritization criteria over the entire test. So when looking at which method covered 100% of the faults earliest, we can see that here two-way covered 100% of the faults earliest because there's 24 faults, and then followed by, this stands for parameter value large to small, parameter value small to large. So the next most efficient was parameter value large to small. And when looking at which faults detect the most faults earliest, it's a little harder to tell because it fluctuates. Here we can see that a couple of the methods started detecting 15 faults, and these are stacked on top of each other, so there are a couple there. But two-way kind of pulls in the lead here and begins detecting the most number of faults, which then is followed by most frequently accessed sequence. And so most of these perform similarly, but these two are the test cases that started with the smallest number of parameter values or requests and went upward, so they took the longest to detect faults. So in conclusion, none of the prioritization strategies is clearly the best one because different methods are good for different applications or depending on the goals of the tester. So two-way is generally a good choice, but for instance, if we have a large number of parameter values, we may want to order the test case by parameter value interaction coverage, or if it is determined that an application has a crucial section, like a crucial part that's accessed a lot and needs to be working well, we may want to order the test case based on frequency-based criteria. So it just kind of depends on your application and the goal. Any questions?